this presentation. My name is Thamer and I'm from Hamburg University of Technology. Today I will be presenting to you our work. Mainly it's my colleague's work. She unfortunately could not make it to the conference about blockchain-based secure archiving of sensor malfunctions in structural health monitoring systems. As a little bit of a background about structural health monitoring systems, those are systems that you install on your civil infrastructure that are aging, facing climate change, and also facing increasing traffic loads in the case of bridges. And the general idea of your structural health monitoring systems, you have your sensors installed on your structure. Those sensors collect data. This data you can translate into information and then into knowledge about your structure. And the main goal of structural health monitoring system is to fill the gaps of visual inspections that happen every 5-6 years, and also act as an early detection system or an early warning system. However, as all the systems in the world, those structural health monitoring systems have sensors that may fault. And those sensor faults could be caused by software, hardware malfunctions, or signal interferences in the case of wireless sensor networks. So you can see it in the data as a complete failure of the data where you don't see it, or you can see it also as noise. So for example, you would have outliers, or you have your data drifting over time. Another thing about wireless sensor nodes, we have something called malicious nodes. And those are sensor nodes compromised by malicious attacks that disrupt structural health monitoring system. And those could be a security issue, especially in the case of critical infrastructures. So tracking both sensor faults and malicious nodes is essential, especially in the case of wireless sensor networks. However, and unfortunately, most our structural health monitoring systems are centralized, so which could create a security issue, as well as could create a single point of failure. So we saw the need for a robust, secure archiving solution offering tamper-proofing capabilities and decentralized data management. And this could be achieved via blockchain technologies. So when thinking about the system, as I said, we want a system for tamper-proof online archiving, and we thought about using something called the Ardor framework, which is an open source public blockchain framework. And we wanted to use it for two specific use cases. The first use case is faulty data. So we want to automatically document alerts when a sensor is faulty. We trigger an alarm, and this is this is recorded. And we wanted to record sensor replacement. So we want to document when a sensor is being replaced after it's faulty. When it comes to the data model that we wanted to send to the blockchain, so first we have the data coming from the sensors when they are healthy, and then we have the alert data, which are the data when a sensor is faulty, and afterwards we have a heartbeat data. So this is an indication if a sensor is faulty or not. This is all in one class called the sensor event, and next to it we have another class called component removal, kind of an indication if a sensor has been replaced, and all of them are in a super class called sensor node data. So this is what at the end we want to send to the cloud. When it comes to designing the architecture of the system, the first thing we thought about is always to keep it a modular add-on that can easily be integrated with structural health monitoring systems. So with the Ardor API, we have blockchain nodes based on the Ardor API that are installed on a central server. And this Ardor API communicate with blockchain nodes via HTTP requests. And then we designed a semantic API that is kind of the middleman between the other clients and the blockchain node. So when it comes to the semantic API, as I said, it's our middleman between the other clients, such as the sensor nodes themselves when they record data, or any other mobile devices that you use to like, for example, say that this sensor node have been replaced. And this translates the sensor node data into specific calls into the Ardor API, and then is used to upload and retrieve data back from the blockchain. For the validation of our concept, we have a test setup consisting of 4 wireless sensor nodes. Those 4 wireless sensor nodes are installed on a test structure, which is excited by a shaking table. And we had an event of 1 hour, so we recorded data for 1 hour. And during this, we recorded first healthy data. Afterwards, we have a faulty sensor. And then this faulty sensor occurs because we injected faulty data into the recorded data by the faulty sensor. Then a fault alarm is triggered, and then afterwards, the faulty sensor is replaced. So we have the whole full scenario. And we wanted to test 2 things, the functionality and the performance. So what I mean by the functionality, we wanted to see if the data is being sent to the blockchain, stored there, and can be retrieved back from there. And when it comes to the performance, we wanted to check the latency, how long it takes the transactions to reach and be retrieved back from the blockchain, and also the cost in terms of blockchain transactions. So for the results, this is, for example, a visualization from the Ardor API. And so we did actually send this data, including alerts, as well as sensor replacements to the blockchain and retrieve them successfully. The average cost was 0.23 Agnes per transaction. When it came to the latency, when submitting the transaction to the blockchain, it was very good latency with 0.014 seconds. However, storing the transaction on the blockchain was significantly longer, with 186 seconds, which is long, in case if you want to have real-time monitoring systems. However, retrieving the data back from the blockchain was very fast. So to summarize what I have said, we have a blockchain-based archiving system for sensor malfunctions, and has been implemented as a modular add-on for structural health monitoring system. We validated this modular add-on or the semantic API by seeing if we can document and retrieve the data from the blockchain. And we noticed from the validation tests that storing the data on the blockchain took way longer than retrieving this data back. When using the Ardor framework, even though it's an open source and have a lightweight API, there was still some challenges when using it. So it's a public blockchain which requires to encrypt the data when sending it to the blockchain. Also, long-term data storage might be affected by the data storage policy of it. And also we noticed another issue when sending high volume data at higher frequencies. So that was it. Thank you.